Hello, my name is Muhammad Zahiruddin bin Muhammad Jamal and I am from RK20. The title for my FYP project is AI Scheduling. I am supervised by Dr. El Sheikh and this is the FYP detail from the FYP page. Basically, I need to create an AI scheduler for a factory that have multiple machine and multiple product that is being tested at the same time. In this video, I will talk about my introduction, literature review, methodology and conclusion. Let's go for introduction. I will explain about what is AI, my problem statement, my objective and my scope. So, what is AI? AI is an intelligence that is demonstrated by machine. AI concept is created in 1950s by Alan Turing, the father of AI. Good AI can make a rational decision like human, but without human emotion, mistake or judgment. And since its birth, AI has grown so much that it has become a field of study in computer science. Let's look into some history, capability and info about AI. In 1950s, AI is born and since then, it has grown into machine learning and deep learning. Initially, AI is a program that can mimic human action, but when machine learning exists, it doesn't need to be programmed anymore. It can learn from statistical data. Then, when deep learning exists, it can learn from a big amount of data such as Google and Facebook. This is the simplified category of AI, machine learning, deep learning and data science. This shows that data science have big relationship with machine learning and deep learning. So, what is the problem that I am trying to solve? First, the scheduling process of a common factory is usually done manually. This will lead to a long processing time since human is slow. And human can make a lot of mistakes such as conflicting schedule and missing value. Finally, the output of manual scheduling by human might not be the best schedule and might be able to be improved, but we cannot see that. So, I want to improve this by developing an AI that can generate a schedule itself. After that, I will try to make the schedule more efficient by reducing idle time, less waiting time, and make a best completion time. Finally, I will analyze the performance of my AI. So, like I said before, this project is aimed for factory operator. This schedule can only be used for factory that have multiple machine and multiple product. If the factory only have one product that doesn't need to be processed simultaneously, they don't need this schedule. The expected output of my project is just a schedule in table form, and I don't automatically control the machine in the factory. Then, we will go to our literature review. So firstly, we will see what AI can and cannot do. AI subfield include neural network, evolutionary computation, computer vision, robotic, expert system for decision making, speech processing, natural language processing, planning and prediction. AI can do a lot of computing, and AI can be used for a situation that require a lot of computation and decision. But since AI is a computer, AI cannot have feeling. It can only play a game, it cannot enjoy a game, give opinion, having interest in the game. It cannot rebel against the program. So AI is limited to its own program. It's not actually a consciousness yet. So to make it easy to understand, AI is just a program that can process a lot of data, learn from it and make a decision. Previously, NASA has utilized AI functionality to create a schedule for Hubble Space Telescope. This is because there is 30,000 events per year to be scheduled. So Hubble Space Telescope need to look somewhere in that specific amount of time. So NASA create the schedule using neural network algorithm. Interestingly, this project is inspired by a factory scheduling work by Fox, Smith and co-worker. Then, Zun Pei Hong used a two-dimensional genetic algorithm to solve their aircraft arrival scheduling and sequencing problem. Since there is many aeroplanes coming from multiple places into a single airport, the situation such as multiple aircraft reaching the airport at the same time is bound to happen, so one of the aircraft need to wait on the air. So to solve this problem, they use two-dimensional genetic algorithm since there is multiple things going on at the same time and the normal single dimension chromosome won't work. So this is the summary of my literature review, where there is a list of previous AI scheduling projects with their algorithm and then there is algorithm comparison on the right. So to process a lot amount of data such as NASA scheduling problem, they need to use neural network scheduling. And for multiple things going on at the same time, we can use two-dimensional genetic algorithm. So I choose to compare between genetic algorithm, PSO, and differential evolution. So genetic algorithm is low complexity but take a long computing time. Differential evolution can be used for data that expand over time, but the accuracy is very bad when it includes a new parameter. Finally, there is particle swarm optimization. This algorithm is faster than genetic algorithm, but it is harder to find the solution that we want since it has slow convergence rate. So based on the simple comparison, I will choose genetic algorithm since it has low complexity even though it have long computing time. This doesn't really matter since the schedule only compute once every week or so. Okay, that's it for literature review. And now for our methodology. So, what is the component for our project? What is the step taken in designing and developing this project? And what do I require to complete this project? So this is my general system flow. It have input, scheduler and output. The input data consists of multiple parameter and component, which is listed in the diagram. Then, for scheduler, it actually have 5 components which is initialize population, evaluation, selection, crossover, mutation, and evaluation. It will provide the best result when the termination condition has been met. And finally, the output for my schedule is this. Only a simple schedule in form of Excel or HTML. This is the use case diagram for my system. The user can edit parameter, start scheduling and view the schedule result. And to make this project simple, a machine can only process one product at a time. So let's see my project design. Project design. This project can be separated into 3 parts which is front end, back end and scheduler. We will go one by one. The front end will have the CRUD feature for machine and product where the user can create, read, update and delete. Then there is the view schedule function where the user can view the schedule or recompute the schedule if they are not satisfied. This front end can be written in HTML, Java or Python and the data will be stored in a database. Then for back end, this is my design. A machine can only do a single process, a product will be splitted into multiple lots, and a schedule will consist of machine as row and time as the column. The lot will be the data inside the schedule. So at certain amount of time, a certain machine will process a certain lot. And to the most important part, this is the design for my AI scheduler. There is 5 general components for genetic algorithm which is create new population, evaluation, selection, reproduction and mutation. The concept will be explained in detail. And I have decided to use two-dimensional chromosomes since there is multiple things running at the same time. Generating a new population. Initially, a two-dimensional chromosome will be randomly populated by any number, and then the first population will consist of multiple random chromosomes. Then our algorithm is ready to run. Next step is the evaluation of each chromosome. There is a few rules that the perfect schedule need to obey, and any chromosome that did not obey this rule will receive a penalty point. A machine cannot process two products at the same time, a product cannot be processed by two machines at the same time, and the product can only be tested once for each testing procedure. Then we will go to selection. The chromosome with the lowest penalty point will be the best chromosome that is selected to be parent for the next generation. But if there is no chromosome with zero penalty point, then we did not get our answer and we will reproduce the parent to get their offspring. This process is named as crossover, where we can see the offspring 1, we have some part from parent 1 and some part from parent 2. And then some of the gene in the offspring chromosome will be mutated. This will ensure that we will not stuck in local maxima. So that's all for our project design. Then what do I require for this project? To complete this project, we will need a Python IDE to develop the algorithm for our scheduler. Then we will have a Java IDE to develop the Java front end or a web page front end. Then we will have phpMyAdmin and XAMPP server to host our backend database. Finally, we can make use of Excel to analyze our data and help in decision making. The skill that we need to have to complete this project is Python, Java and SQL programming. Okay. So we have seen our introduction, literature review and then our methodology. And now we need to go to our conclusion. So, the objective and the problem statement has been identified. AI scheduler project has been already done in the past, which include big data set and multiple things running at the same time. This project is still in designing phase, so there will be improvement in the future, but based on previous project, I have decided to use two-dimensional algorithm. This project is possible and does not disturb any public safety or privacy. So that's all for me. Thank you.